All right, so we are going to be doing page 76 and 79 today. So it's just 2 pages. We're just going to jump in between because I would rather us get it all done in one day than spend it forever on other parts. Okay, so we're going to start on page 76, which has a whole lot at the top. Like whole lot. Because this whole paragraph's up there, which gives you so much information. Attendance, I need to remember to do that. So you guys get your books out. I'm going to finally remember to do attendance in here because Ms. Rice is in here to do it for me. Let's see.
Secondary time.
All right, there we go. Now I did it. Yay. All right, so at the top of this page, it talks a whole lot about a gravity formula. So we started talking about this the other day with that watermelon conversation we had where I was throwing a watermelon off my roof and then we threw a ball in space. So this is a more specific gravity equation. It's still not perfect, but it's getting closer. You will not have to memorize or pull up a gravity equation, so don't freak out about that. But this is closer and closer to how gravity actually factually works in the real world. Thank you, my dear. There you go. And they give us this kind of a form of equation. It's 1/2 times the g, the gravity force, which honestly just depends on the units you use. T squared plus V naught T. V naught is this one here. This V with the teeny tiny 0, we read that as V naught, like this. Naught. Okay, my handwriting looks like a 7-year-old wrote that, but that's... I'll fix that. N-A-U-G-H-T. Naught. Like 0. All that means is that's your starting place. So your initial velocity of V naught, meaning how fast it goes. Your initial height of H naught. Again, starting place. Whenever we say naught, it just means 0. H is 0, T is 0. Thank you, sir. The naught thing probably will show up in other stuff as we do things like more physics-based equations, because all it means is when we start, how's it doing? For it's how's it moving, velocity, how's it tall? How high is it? When we start calculating stuff. That's all naught means is when time is 0, what's it doing? It just sounds all super duper fancy mathy. And then in the book, they give you these equations. They give you the meters equation and they give you the feet equation. Only problem is, the meters equation they give you is wrong. They made a mistake. They didn't include the -1/2. So you can fix it. I don't know that we actually use it, but it just feels wrong to leave it there. So this -9.8 is wrong. It should be -4.9 T squared. You can do the whole thing if you want to. Plus V naught T plus H naught. More often than not, we're going to use the feet equation. But it honestly felt wrong to have you have a equation that was wrong to reference. because what they did was they forgot to include this minus 1/2, and they just took the strength of gravity, which is what these numbers are. It's how strong gravity is. Gravity does 32 feet per second squared, but the equation uses the minus 16 like we did with our watermelon problem. Because that's exactly what we used, was that minus 16 squared. So what we're going to do now is we are going to use these equations, start looking at things and how they compare and what different kinds of equations tell us. So we're going to look at number 1 here. This is honestly a very famous kind of experiment here, and to think about it. We've got a piece of paper and a hammer are dropped off the top of the school, which is 90 feet high. They are both dropped from a still position, so I'm not throwing it down, we're just dropping. And we're ignoring air resistance. It's not a thing in this world, so it's like being in a vacuum. Air resistance is not a thing. Which object is going to hit the ground first? So we're going to look at this equation and we're going to kind of fill in the pieces we have. So let's start with the hammer. When I go to write an equation for it, we're going to use feet because our school is listed as 90 feet high. So we're going to use the feet equation. So I can figure out the height of the hammer. Using that equation, we've got minus 16 t squared. I don't know time yet. We're asked to find the time when they hit the ground. So it's okay to have a t. Plus v naught. How fast is it going at the start of this experiment? Got you. All you need to do is use words. There we go. How fast is it going at the start of the experiment? What is my initial velocity? How fast? 0, because I'm not throwing it. I'm just going to drop it. So my v naught is 0 times t. Plus, what is its height at the start? What is h naught? 90. Okay. Can I simplify this at all? What's 0 times anything? 0. So do I need to have this term here at all? Nope. So the equation for the hammer, if we drop this and there's no air resistance, is 16t squared plus 90, or negative 16. We're going to do the same thing for that piece of paper. Again, I'm going to start with my equation. H of t minus equals negative 16 t squared plus v naught t, my initial velocity. How fast is my paper going at the start? 0, because I'm not throwing it. 0t plus, how high is it? What's my h naught? 90. They start from the same place. So again, we can kind of simplify this. Negative 16 t squared plus 90. What do we notice about those two equations? They're the same. They have the exact same equation. That is the wrong pen. So which one is going to hit the ground first? Same time. So they would hit, or land, or whatever verb we're choosing. Yeah. They would hit the ground at the same time. This is a very, very, very famous science experiment that was actually thought up before we had the technology to do it. So like this was theorized back in the ancient Greece, Socrates kind of days. And then they finally did it when NASA built, gargantuan vacuum chambers where they could do it with no air resistance, and air resistance wasn't a thing in the way. Because mathematically, they should hit at the same time. Gravity is not affected by the mass. The thing that stops the paper and hammer from hitting at the same time out here is all the air in the way of the paper. And it did work. They did a feather in a bowling ball, technically. And they hit at the same time when air was not in play, because gravity is a constant force no matter what it weighs. So it's a very, very famous experiment. And the video of it's kind of really cool. But I didn't have it. So, but you can find it on YouTube, I'm sure. Okay, so we're going to be playing with some of these equations and messing with them. Let's look at number 2. It's at the very bottom of that page. So it's on the same page. We still have those equations there to look at. And we're going to fill in another equation. We've got a potato fired from a spud gun at a height of 3 meters and an initial velocity of 25 meters per second. We're going to write the equation of the potato projectile. They look to Jamie tongue twisters. And I want to know, how high does the potato reach? And see if we can figure it out. So, are we going to use the feet equation or the meters equation? For meters. I was going to say we can tell because we have meters. Meters. So let's not make life harder, and we'll just keep everything in meters. So our meters equation, I'll write it down on the screen so we have it. This is the one that we needed to fix, that negative 4.9 t squared plus v naught t plus h naught. And we're just going to take the information we have and substitute it in. H of t. This negative 4.9, that doesn't change. We don't know a time, and that's okay. We can keep that as a t squared. Plus v naught. What is our starting velocity? What's our v naught? $25. So we're going to substitute that in place of the v naught piece. 25t plus, what is our h naught? What is our height at the start? 3. So sometimes all we have to do is take the pieces and substitute them in. So what we have here is, oh, beautiful art. This dude, I'm going to assume he's standing on a platform because 3 meters is awfully high for a human to be. He's shooting a potato gun, and it's going to go like this until it hits. And you know, I am a fine artiste. I want to know, how high does the potato go? Where am I going to find that information? How would I, where on my picture would I see it? What you got, Amber? On the what? Not the 3. The 3 is actually, right here, let me get the color. The 3 is actually where the launch starts, where his initial height. So that's my 3. And it might not be in our equation. That's entirely okay. How can I figure out how high it went? You guys thought about this a little bit with your catapults. When it reaches its maximum height. This guy up here. This is my maximum height. There's a spot right here where it absolutely reaches that. Does anyone remember what that's called? What is the name of that point? He has a special name. Starts with a V. Not velocity. Velocity is a speed. Huh? Not slow. Not our y-intercept. Good words, though. I love those words. Starts with a V. Has to do with parabola. Vertex. There it is. It's our vertex. So whenever we're looking for like our maximum height or our minimum, how low does it go? How high does it go? That's when we're looking for our vertex. This equation is in our standard form or in our general form. That is what that form is called. Standard or general form. It's called both. That's why I wrote them both up there. I just don't want you to be confused. It's not the standard or general form. That form does not actually tell us the vertex. It tells us how high dude is. Dude started at 3 meters. I can find that. I know my initial velocity. That's a pre-cal thing. If you're looking at that, that's technically a derivative. But we don't need to know the velocity hardly ever. But I know how high he is from this equation. I don't have a way of finding my vertex from this equation yet. We will. We'll get there in a couple weeks. But we're not going to get there right now. So at this point, the only way to find out how high it goes is to go online and graph it on Desmos. Which we don't necessarily need to do. I'd rather spend more time looking through our other forms. Which I did find my forms poster. And go through that. So in standard form, it doesn't really tell us the vertex. Can we guess which form does tell us the vertex? Yeah. This one. Our vertex form. It's going to tell us our vertex. There's a clue in the name. The H and the K would be our vertex. This is our standard form. It's up in the top. The C, that's our 3 over here. That's what tells us our initial height, where it starts. That is not what I meant to do. That is actually our y-intercept right here. So our standard form gives us our y-intercept. They asked for our vertex, so yeah, that's not going to help. Okay. Questions on this one? Because we're going to jump a couple of pages. Because the next page is another one that's very similar, but a whole lot of thinky. And then the next one is that Angry Birds picture that we looked at when we started our catapults. So we're going to go to page 79. And we're going to do both of these, and we're going to think about our forms. Okay. Page 79. So this one, they've gone past the points of actually giving us context. They're just saying the points of a parabola are these. And we're asked to write the equation. So we have some points here used to model a parabola. We want to try and write an equation. Which one do we think might be most useful for this? We've got our standard form, our factor form, and our vertex form. Which one of these is going to be helpful here? I've got these two pieces here. These two I want to draw your attention to. What values do we know? What numbers do we have? X and Y, right? on both of these pieces, y is 0, right? Which means these 2 points have a special name. Does anyone remember what they are? When my y is 0?
Oh, sorry.
Dude, come on. That was like the least subtle single finger high five ever. What does it mean when I have a number in the x and my y is 0? If we think about a picture here. Try to look at a graph. If we have negative 3, 0, where's that going to be? Is it going to be down here, or is it going to be over here? Left or down? For negative 3, 0. Left. It's going to be here. How about for 6, 0? Is that going to be right or up? Right. These 2 pieces have a special name. Does anyone remember what they are? Our x-intercepts. These are my x-intercepts. When we're dealing with like graphs and things and parabolas and polynomials and all that kind of jazz, x-intercepts have a couple other names as well. We can also call them roots or solutions or zeros, because my y's are 0. So that word roots, does that give us a clue on which equation we might want to use to help write an equation here? Look at these equations really closely and see if something like roots would help us pick which form we might want to look at for my roots. Which one of these might help with roots? What letter does roots start with? So then we're going to use our factored form. Yeah. When we have roots or x-intercepts, we're going to try and use that factored form. I have this set to lock. I do. Huzzah. That makes it easier for me to write. So we're going to use our factored form. I'm going to put f of x, my function notation, a x minus, this is root 1, x minus root 2. It genuinely does not matter which is root 1 and which is root 2. But all we do is we're going to take the numbers that aren't 0. So what we have right now, just from that information alone, we've got our f of x, or our y, I don't care what you put it as, some number a. We're going to have x minus negative 3 and x minus 6. That minus negative 3, that kind of looks icky, right? I'm going to switch this to y because I'm too lazy. A. X minus negative 3 really means x what? 3. What does the minus negative turn into? Plus. So you have x plus 3, x minus 6. All right, it's a start. I have 3 variables here, though. I don't want to do that. I would like to just be x and y. So I do have more information that they gave us. I have my 2 x-intercepts that gave me my 3 and my 6. And then I have more information here. I have a point for negative 5. I could take that and go, all right, x is 4, y is negative 5. I can put a dot here. And I could get myself a better view of a parabola here. That lets me know which way it's opening. That lets me connect it up. That doesn't really help me with my equation. What I can do with that in order to help with the equation, to figure out what this a value is do a substitution. Substitute it in to try and figure out what a is. So I'm going to come down here give myself a little space. And we're gonna sub in. And it's 4, -5. So my y is -5. So -5 equals whatever a is. And that 4 goes in place of both x's. So we're going to have 4 plus 3 and 4. Okay, fix that because that's bad. Minus 6. I'm good at writing. And all of this down here, we substituted what we knew into here. This is just 1, 2, 3, 4, 5 numbers in a single letter. We can solve this. -5 equals a times 4 plus 3 is 7. And 4 minus 6 is what? What's 4 minus 6? -2. What is 7 times -2? -14. So we have a times -14. How do I get a by itself? I want to know what a is. That's a times negative. Or you can leave it in its parentheses. That's the other way to do it. Oops. How do I get the a by itself? What's happening between the a and the -14? They're being multiplied. How do I undo that? Divide. And we're going to get a not pretty number. So I'm going to divide both sides by -14. That's going to give me 5/14 is my a value. Gross. But real world, when we do parabolas and things, we very rarely get nice, pretty numbers. And all that tells me is I can come up here into my equation and say, all right, a is actually 5/14. And now if I wanted to know how high if I wanted to know what happened at time 2, I could figure out what happened. If I wanted to know what happened when x was 300, I could do that. If I wanted to know what happened when x was -4, I could do that. I could substitute that in and get it to spit out a whole value. The way to tell if that's going to work is if when I substitute in everything I have, I just get down to a single variable, I can finish it out. If we get everything I know substituted in and we wind up with 2 variables, I can't get it all the way down. So we're going to do the next one on this page, and that's going to be the last one for today. It's very, very similar vibe. We've worked with standard form. We've worked with factored form. Oh, snap. I wonder what's going to be next. We've got the vertex of a parabola here and its y-intercept. We're going to see if this is enough information to write the equation. So if I know the vertex of a parabola, which equation should we probably use? Which formula? This is our code word right here. If I know the vertex, which form are we going to use? Vertex form. So we've got our y equals a x minus h squared plus k. Vertex form means literally our vertex is h comma k. The same h and k that are in this. It straight up gives us 2 of the values. So that's what we're going to do, is we're going to plug those values in and see what we got. So I have y equals a times x minus my h, which is 15, squared, plus my k, which is negative 30. Plus negative 30, that feels weird. What does that simplify down to? Plus negative 30. Does that become a plus or does that become a minus? If we simplify this, plus negative 30, does that become a plus or does that become a minus? Minus. I just write it in there so that we see it and remember that this is a plus here. But in reality, you don't have to. Same thing. So that's what I get just from having the vertex and plugging that in. Do I have another point that I can plug in for my parabola here? What we know is we know our vertex is at 15, negative 30. I know I've got a vertex here. That's my top of my parabola. So it's going to do something like that, probably. Do I have another point to plug in? Yeah, this is 0, 25. It's still an x comma y. I can still plug in 0. That's totally fine. What we have here is we're going to take and we're going to substitute in. My y is 25. I don't know a. My x value for this 25 is 0 minus 15 squared minus 30. Could we solve that and figure out what a is? Yeah. I only have one letter here. If there's only one letter, I can absolutely get there. I can solve it down. So let's simplify as much as we can. We have 25 equals a times, what is 0 minus 15? Minus 15. Somebody's music's so loud I can hear it right here. Turn it down. Even over the heater, I can hear it. So then let's simplify again. What can I simplify next? What's going to be next in my order of operations here? I have one more thing to simplify. Negative 15 squared. What is negative 15 squared? Watch your parentheses. It's really, really important that if you put it in the calculator, we put parentheses. Oh, it's going to be a jerk about it. My computer hates my calculator right now. Never mind. So you got to put parentheses around your negative 15. It should be positive because negative 15 times negative 15 is going to be positive 225. So we have a times 225 minus 30. And I want to get a by itself. I want that guy by himself. What am I going to do next? Add 30 to both sides. Good catch. Thank you for doing that. So what we get is we get 55 equals, I'm going to switch these around because a 225 sounds weird. 225 times a. How do we get what a is? Divide both sides. And if you use the yellow calculators, because the yellow calculators are awesome, it will simplify it for you. And what we have is 11/45 is our a value. So we could come up here to get our equation, which is what it says to do. If so, do so. We know our y is, the a value is 11 over 45. X minus 15 squared minus 30. This is our whole equation here. Okay. And so I know we just did a whole lot of. And we have about 8 minutes left. But that's it for today, notes-wise. I want to talk for a second about tomorrow. We're not doing that one. There we go. So there is, in fact, a homework for tonight, because that's how it hits in the schedule. It is actually the next page. And it's mostly thoughts and expanding on your thoughts. There is also an e-learning assignment for tomorrow, because we have to have you do a thing. I'm not going to do notes. Like, you have to join the Zoom call for attendance. When you join the Zoom call, I don't care. Okay? So anytime in that 8 to 11 window, I will have the Zoom on, I will have the Zoom open. It's the same link for all my classes, same link all day long. It'll give me a little ding when you join the waiting room. I will mark your attendance. I will let you in. Once I let you in, I have your attendance marked. You're free to go. If you have questions, I'm here. I'm more than happy to help you. I will answer anything you want. Old stuff, new stuff, working on stuff, questions, whatever we got. I'm here. I'm not going to go through notes with you. If you pop in at 10:59, I will still mark your attendance is here. Okay? It's just one of those things. They are making us take the attendance on this. And then they told y'all on your day off you had to wake up at 8 a.m. It's like they haven't interacted with a high school in 20 years. Just saying. Logistically, it doesn't make any dang sense to give y'all the morning shift. Because you ain't coming at 8 o'clock. I know that. Very few of you will be awake by 11. But if you pop in before the end of the scheduled e-learning day, before 11, I'll mark your attendance. Okay? But I'm not going to be petty about it and any of that. Okay, so there is an e-learning assignment. There is a homework assignment for tonight, technically. So work on both of those. You got all of tomorrow to do it. You've got another 6 minutes in here to do it. They're not super complicated. The e-learning assignment is very, very similar to what we did today. Can you write an equation and do the equation? The assignment is it a quadratic or not? Okay, so again, work on stuff. Let me know if you have questions. We are going to have a quiz before spring break, that Wednesday before spring break, because Thursday's the college career fair. Friday is the Friday before spring break, and therefore useless. So, because everybody's checked out. So the Wednesday before spring break, we will be having our quiz on this first chapter. Okay, so let me know if you have any questions. There's 5 minutes left in class. Rock on.